Back, Chapter 1, Section 1.7. Here we look at the precise definition of a limit. The intuitive definition of a limit is inadequate for some purposes because such phrases as x is close to 2 and fx gets closer and closer to L, these are vague phrases. In order to be able to prove conclusively that limit x approaching 0, x cubed plus cosine 5x by 10,000 is 0.0001, or limit x approaching 0, sine x by x is 1. Notice this is not straightforward to understand what's going on here. We must make the definition of a limit precise. Okay. To motivate the precise definition of a limit, let's consider the following function. Fx is, it's piecewise defined, 2x minus 1 if x is not 3, and fx is 6 if x is 3. You see, the value at 3 is 6, but out of 3, away from 3, you follow the rule 2x minus 1. Sorry. Intuitively, it's clear that when x is close to 3 but not equal 3, fx is close to 5. Say you take some number close to 3, say 3.1. You substitute 3.1 times 2 is 6.2 minus 1, 5.2. You see, it's close to 5. Closer you get to 3, closer the value will be to 5. In other words, limit as x approaches 3 of fx is 5. Now, to obtain a more detailed information of how fx varies when x is close to 3, we have to ask the following question. How close to 3 does x have to be so that fx differs from 5 by less than 0.1? You understand? Look, as x approaches 3, fx approaches 5. So how close do you have to be to 3 so that fx is different from 5? The difference between fx and 5 is less than 0.1. Notice the difference could be positive or negative. In other words, now let's understand the meaning of distance. Distance from x to 3 is absolute value x minus 3. You see, x could be bigger than 3 or less than 3. So the distance is absolute value x minus 3. And the distance of fx from 5 is absolute value fx minus 5. Why do we take absolute value? Because fx could be bigger than 5 or less than 5. You see, greater than 5 or less than 5. So absolute value ensures you get a distance. Distance is going to be a non-negative number. All right. So for distance, you take absolute value. So the question is to find a number delta, that symbol is Greek letter delta, such that distance between fx and 5 is less than 0.1 if distance between x and 3 is less than delta. But x is not 3. So you see, this tells us x is very close to 3 and fx is very close to 5. How close to 5? Distance between fx and 5 is less than 0.1. So how close should x be to 3? Well, we need to minimize that distance, you see, reduce that distance. Now, if absolute value x minus 3 is greater than 0, then x is not 3. You see, if x is 3, absolute value is 0 on the left, right? So if you want to be greater than 0, x has to be not 3. That means all of this is same as saying distance between fx and 5 is less than 0.1 if 0 is less than distance between x and 3 is less than delta. Notice 0 less than absolute value x minus 3 is less than 0.1 over 2. See, if you make sure that the distance is less than 0.5, then what happens here? Fx is 2x minus 1, 5 is 5, absolute value fx minus 5 gives me absolute value 2x minus 6. You can get the 2 out. 2 times x minus 3, absolute value x minus 3. Absolute value x minus 3 is less than 0.05, and that gets you 0.01, 2 times this. In other words, if absolute value x minus 3 is less than 0.05, then absolute value fx minus 5 is less than 0.1. Notice how we speak in English. This quantity, this phrase is true if this phrase is true. That's why we first assumed this, which resulted in this. Okay, assuming this resulted in this. In other words, this will happen if this holds. So, an answer to the problem is, well, we were looking for how close x should be from 3. Well, x should be within 0.05 distance from 3. X is within a distance of 0.05 from 3. Then fx will be within a distance of 0.1 from f. Okay, so if we change the number 0.1 in our previous setup to a smaller one, then all we have to do is divide by 2 yet again, and you get similar argument. Okay, fx, absolute value of x minus 5 is less than 0.01 if 0 is less than absolute value x minus 3 less than 0.05. I take a smaller distance for f. I get a smaller distance for x. Okay. Why do I have to divide by 2? Let's go back to the argument. You see, fx minus 5 brings out a 2. That's what. So 2 times the distance I'm allowed for x gives me the distance I'm allowed for f in this particular case because of that 2, you see. And that's why if I'm told how fx should be within such distance, how close should x be from 3? Well, take the distance, divide by 2. Take the distance, divide by 2. Okay, these numbers that fx is allowed to be within distance, these numbers are error tolerance. These are called error tolerance. For 5 to be the precise limit of fx as x approaches 3, we must not only be able to bring the difference between fx and 5 below these numbers, we must be able to bring it below any positive number. You see, we just saw 0.01 and 0.001. In the previous page, we saw 0. Well, these are just 3 numbers. For any number, any positive number, we should be able to do this. All right. So, and by the same reasoning, we can write epsilon. This symbol stands for epsilon, the Greek letter epsilon. So, we can write epsilon for an arbitrary positive number. Then, absolute value fx minus 5 is less than epsilon if 0 less than absolute value x minus 3 is less than a delta, and that delta is epsilon by 2 divided by 2. Okay, so this is a precise way of saying that fx is close to 5 when x is close to 3, because 1. says that we can make the values of fx within an arbitrary distance. So epsilon can be any number, any positive number. Arbitrary distance epsilon from 5 by restricting the values of x within a distance epsilon by 2 from 3. But x should not be equal to 3. Okay, that's why we have that part of 0 less than absolute value. This part makes sure x is not equal 3. This part makes sure x is within a distance of delta from 3, and if this holds, then this holds. Okay, now we can rewrite this particular expression in a following way: 3 minus delta less than x less than 3 plus delta, and x is not 3. So notice this is not very difficult to see. What it means is distance between x and 3. Let's zoom in. Distance between x and 3 is less than delta. So from 3, if you go to the right, the maximum you can go is 3 plus delta, but you cannot even touch 3 plus delta. The minimum you can go is 3 minus delta, and you cannot touch 3 minus delta. I hope it's clear. So this particular interval forces x to be within distance of delta from 3. And that's all we are saying. X should be between 3 minus delta and 3 plus delta. Then if that happens, then fx will be within epsilon distance of 5. That's all this is. Fx is in this interval. So fx is between these two numbers. And that's what. You see, my fx function is 2x minus 5, right? So that's a line. And when x is within this interval, if you notice, fx is within this interval. All right. So now with that understanding, we'll come to the precise definition of a limit. Okay. We'll continue in our next video.